just remind me, what are the parameters that we need to define a normal distribution? So if you have a random variable x, which is distributed normally, what are the two parameters that we need? Absolutely, it's the expected value. What value do we expect? Mu, the mean, right? What else? Variance. Fantastic. So remember, in this course, we always deal with the mean and the variance. Just remember that depending on where you look, some sources just put the standard deviation there instead. But in this course, it will always be the variance. Okay? Okay, good. And then we looked at this idea of the shape of the distribution, which is this kind of bell curve. Okay? Now, we said that the value in the middle should be the expected value. That should be mu, right? And then we basically split up this distribution according to standard deviations above and below the mean. So how many steps, how many standard deviations did we say we look at above and below the mean? 3, right? So the majority of our data should lie within 3 standard deviations of the mean. Is that okay? Yeah? So this would be mu plus 1 sigma. This would be mu plus 2 sigmas. This would be mu plus 3 sigmas. Is that okay? Yeah? All make sense? Good, fantastic. And then this in the other direction should be mu minus 1 sigma, this would be mu minus 2 sigmas, and this would be mu minus 3 sigmas. Okay? And if you remember yesterday, we kind of divided these up into regions, and we knew from evidence roughly how much data we should expect within each of these regions. Okay? So can anybody remind me how much data did we expect less than 3 standard deviations below the mean? Is it 0.35 or 0.15? 1.5, I think, isn't it? Yeah, fantastic. Okay. How much data should we expect within 3 and 2 standard deviations?
2.35.
Good, 2.35%. How much data should we expect between 2 and 3 standard deviations?
13.5.
13.5. And how much data should we expect between 1 and the mean? 34%. And are you happy that because this distribution is symmetric, we expect exactly the same proportions each side of the mean? Okay, so expect 34% here, 13.5% here, 2.35% here. Anything above that is 0.15%. Does that make sense? Okay, so actually with the normal distribution, this is different to when we were dealing with this. Okay, because usually when we deal with discrete distributions, we look at the probability mass function. In other words, what is the probability that x is equal to some value? Yeah, that's what we tend to deal with the discrete distributions that we've already looked at. Okay, as well as, of course, the cumulative distributions as well. But the probability mass function is important here. When we look at the probability, density function for a normal distribution, it was a horrible formula, right? It was like the 1 over sigma times by the root of 2 pi e to the negative x minus mu all squared all divided by 2 sigma squared, yeah? So it was a horrible thing, right? It was a horrible thing. I said we don't tend to look at this. We don't tend to look at the probability density function for the normal distribution. Instead, what we focus on is the cumulative distribution function, okay? Which is the probability that x is less than or equal to some value, yeah? So we tend to look at cumulative probabilities when we deal with continuous, and we tend to look more at discrete probabilities when we're dealing with exact values, yeah? So probability mass function. So does that make sense? That reminder of what we did yesterday? Yeah, it's all good?